Welcome back to our channel, Motormouth Uganda. We have just had an interesting discussion on batteries. Now we are going to talk about alternators. Our resident engineer will tell us what exactly these are, what do they look like, and what do they do, how do they do it, and how best to ensure our vehicles are well maintained and these things are kept in good condition and good shape. Welcome, Engineer Ivan Chivuka. These alternators, I think they fall in the same category of those things which, if you are not familiar with your car, the mechanic may tell you, do you see this? And if you say no, now you are ripe for being exploited.
Kawakaweddemu.
Wakaweddemu. Alternator ogiraba nti ate yeeriwo eyo nti aha kati jangu kugala.
Yeah. Thank you for that brief introduction. Like Alan said, we've just done the video regarding batteries. For all our viewers, if you haven't watched that, to follow the alternator one better, it is very important for you to go back and watch the video about batteries. Batteries are storage, electrical storage. Should I call them equipment, paraphernalia? They store electrical charge to run electrical items. We have them in cars, on various electronic items, cars. So when the engine is not running for a normal car, diesel or petrol, when the engine is not running, your battery is the source of your electrical power you have on the vehicle. Now, when it is the battery is supporting the electrical system on your car, it is being discharged. At some point, it has to be recharged. The chemical process in the battery has to be reversed. So it is reversed then during charging. So it goes forward, goes backwards, goes this way, back and forth. It's a sustainable form of having electrical power on your vehicle. It discharges, it has to be charged. It's not an infinite source of electrical power. Anyway, to understand this better, again, I'm going to share a presentation where I'm going to show you can you see the presentation now about automotive charging systems?
Yes, I can see it.
Yes, so I'm going to show you the automotive battery charging system on cars is usually made up of the alternator. So we are going to discuss mostly the alternator. There are some vehicles. I've had some prototypes that have been designed to work based on using solar power. Basically, they have batteries with solar panels on top. Basically, those don't need alternators because the solar panels will be charging the batteries on the vehicle. Electric cars, we all know you have to go some charging point to charge the battery on an electric car. But for the ordinary vehicle, ICE, internal combustion engine vehicle, that uses diesel, petrol, or whatever fuel there is, hydrocarbon fuel there is, you will need a system when the engine is running that can charge up your battery. The battery works mostly when the engine is not running to operate the electrical systems, whatever electrical systems you have on the vehicle, and also to start the internal combustion engine. After that, automatically, the alternator comes in to charge the battery up so that you have juice, you have electrical juice next time the engine stops. Or else, the vehicle would not be sustainable. It would be like an electric car. You run out of juice, car with them. So cars have alternators which make up the bulk of the vehicle charging system. Like I mentioned earlier, the electrical demands made by modern vehicles are considerable. Therefore, the battery's charging system must be able to meet these demands under all vehicle operating conditions. That is when the engine is running, whether the vehicle is slow, stopped, but in idle, whether it is going very fast. The alternator or the charging system must be able to operate in all these conditions and still be able to charge the battery very fast. Remember, at the end of the previous video about batteries, we mentioned that the chemistry used in these batteries is lead acid, which has a disadvantage of charging slowly. So you need an alternator that can try to charge these batteries very quickly. Otherwise, a vehicle will become unusable because there is no electrical juice on the vehicle, because you consistently may have or suffer from flat batteries. So the main component of the charging system is the alternator. In the old days, it used to be a dynamo. A dynamo is kind of different from the alternator. They are not the same thing. A dynamo actually produces DC, and alternator produces AC. They do a similar job, but the alternator produces AC. And on most modern vehicles, with the exception of its associated wiring, the alternator is more or less the only component in the charging system. It's the major component, plus its wires and the light on the dashboard that warns you if the vehicle is not charging. So the alternator generates SC, like I said, alternating current, but must produce DC at its output terminal, going to the battery and to operate the electrical components of the car. When the vehicle is running, the alternator must be able to supply enough electricity to operate the electrical components of the car to stop draining the battery. At the same time, it should be able to quickly charge the battery to replace whatever juice, whatever electrical juice you lost when you operated the car without the engine running and when you are starting the engine. So the output of the alternator must be a constant voltage regardless of engine speed and current load. That's a very important aspect, because like we've just said, the alternator, the way it is built, it produces AC like a generator. Like the generator you have, these small generators we have in the shops or businesses or houses. When you lose power from the mains, or when you are camping, you run that generator. The power it produces is AC. It is similar to what the alternator also produces, because the alternator is being operated off the engine, and the engine is rotary. So the alternator also has the rotary parts, as we shall see. So the charging system requirements are as follows. The alternator should be able to supply the current demands made by some or all electrical loads on the vehicle. I mentioned that. Even when the vehicle is running, in fact, you have more electrical loads or consumers on the vehicle when the vehicle is running. So the alternator should be able to give those power, and then on top of that, supply whatever charging current the battery demands. A very thirsty battery, one that is low on charge, will demand for a lot of current at the start of the charging session. As it fills up, the current will become smaller and smaller. But at the beginning, the first several minutes, it's taking a lot of current. So the demand on the alternator is greatest most times when you've just started the engine. The first 10, 15 minutes, That's when the alternator suffers the biggest load, when it supports the biggest load. So the alternator should be able to operate at idle speed, even with all those demands. It should produce constant voltage under all engine running conditions. You cannot have voltage going up and down, 20 volts, 8 volts, whatever. No, it should be constant. I will mention some numbers as we go along, you will see in a few slides. So it should have an efficient power to weight ratio. In other words, it should not be a big item. It should not be something that is big, because when you fix it in the engine bay, it's going to take up a lot of space. And also it should not be something that takes a lot of power away from the engine, because the engine's primary role is to give you the power of propulsion, the motion of that the vehicle achieves. That's where most of the engine power is directed. So alternators, air conditioning compressors, all those other things, and even some cooling fans that are mechanical, all those rob power from the engine. So a good alternator should be one which takes very little power and takes up very little space in the engine bay. So that alternator should also be reliable, quiet, and resistant to contamination, because it faces all sorts of environments, but it should be quiet when operating. It should not be whining and making all sorts of noise. Should be reliable. Most alternators I've noticed tend to quit around 100, between 100 to 150 kilometers, 100 to 150,000 kilometers mileage on the car. So an alternator should last that long. They are trying to extend, the designers are getting better and better at it. So they are trying to extend their life. But they also require low maintenance. They should not have maintenance issues. You should just install it and it works, period. Should ideally not be serviceable, although in the end, when alternators get problems, we end up having to service them or to replace them. So the alternator should also provide some indication of correct operation. That's why you have that light that warns you on the dashboard when the vehicle is not charging. Usually that light is in form of a battery. Usually it is red, sometimes yellow, but usually red. To warn you, when you see that light, it's telling you the charging system is not working. So that's what a typical alternator looks like. You can see internally there are things like the stator. The stator is when you peer through the hose on an alternator. I don't know, Alan, if you've seen those thick copper cables. Those make up the stator. And then inside there's a rotor, which is like a magnet. That magnet keeps rotating within the stator, and there's electromagnetism going on to produce that electricity. The story is a bit longer than that. It's a bit more technical and scientific than that. Just suffice it to just know that the magic happens, electromagnetic magic happens inside the alternator, and out comes the electricity. So a typical alternator will look like that. And on this end, of course, toward the left, you can see that's the pulley of which the belt turns. The belt runs and then turns the pulley. The pulley has a shaft at the back, which goes inside the alternator and is connected to the rotor. The rotor has magnets on it. And so those magnets will be rotating inside the stator, and that's how electricity will be produced. So if the belt breaks, the alternator is not going to be working. And that's one of the things people check first when the alternator shows signs of failing. So the alternator strategy is as follows. When the voltage is less than what the battery is producing, when the voltage produced by the alternator is less than what the battery is giving the system, That it will happen when either the engine is very, very slow, too slow, or not running at all when the engine is stopped. The direction of current flow from the battery to the vehicle is from the battery to the vehicle. So the alternator, in this case, if it did not have protection, would be a consumer because it is directly connected to the alternator 24/7. But inside the alternator are diodes which prevent current flowing back through the stator. So this prevents the alternator from becoming a power consumer when the engine is not running. So once the alternator output is greater than the battery voltage, that is when the engine is running, current will flow from the alternator to the vehicle loads and also the battery. The battery now becomes a power consumer. So the source of the power now will be the alternator, and the battery will be one of the power consumers. Therefore, the alternator output voltage must be above battery voltage at all times once the engine is running. That is why before you start the engine, the alternator light, warning light will be on. That's normal. But once the engine is running, the alternator light should be extinguished because at that point, the voltage, the system voltage will be higher than the voltage battery. And that is, there are circuits inside there which will ensure that the light turns off. Once the alternator is not able to produce voltage that is higher than the battery, that light will turn back on. So the actual voltage used is critical and depends on a number of factors. A figure of about 14 volts is the accepted charging voltage for a 12-volt system. Although on some vehicles these days it is managed all the way down to 13.0, 13.1, 12.9, yeah, depending on the engine load. There are some smart alternators these days which play around with that number, but ideally 14 should be a good number to charge a battery, to charge a 12-volt battery system. Commercial vehicles which have 24 volts, which use 24 volts or have 24-volt batteries, generally employ two batteries in series at a nominal voltage of 24 total. Therefore, the accepted charge voltage is doubled. So the alternator, the voltage coming out of the alternator is higher. It's maybe 28 volts or something. These voltages are used as the standard input for all vehicle loads. In other words, whether the engine is idling, speeding away at 200 kilometers an hour, whatever, the battery voltage should not be changing much. So I also included here in the presentation some schematics for alternators. They show to anybody who has some bit of engineering knowledge, they indicate how the alternator works. But on the left, you can see the schematic of the rotor rotating, and it rotates with the magnet, which has north-south poles. And then that rotor is rotating within the stators. So the stators now produce AC, as you can see in the image. And then on the right-hand side, you can see a wiring schematic, which shows that they are diodes. Diodes are electrical components which prevent electrical power from flowing in a certain direction. So they allow electricity to flow in one direction, but not the other. So they prevent the backflow of current from the battery when the alternator is not working, when the engine is stopped. That's why you are seeing in that image, you are seeing a lot of diode. And then there is also a rectifier. So you essentially have two things that the alternator is doing. It produces AC, which it must turn into DC. And then after it turns it into DC, the DC must be at a certain level. It should not be changing a lot. Yeah, if anybody knows anything about electricity, you would understand that for sources of power, once the speed increases, the voltage also tends to increase. So these circuits are internal to the alternator, but they are to manage the voltage and power and current coming out of the alternator. Make sure it is within the specs of doing the right job on the car so that the electronics on the vehicle are not fried and the battery is also charged. So obviously you need some form of voltage regulation, which is what I've been discussing. So this is a very difficult task, as I've just been mentioning, because of the constantly changing RPM and loads on the vehicle. So the output of an alternator without regulation would rise linearly in proportion with engine speed, but we don't want that for obvious reasons. So alternator output is also proportional to magnetic field strength, and this in turn is proportional to the field current. It is a task of the regulator. There is a component called the regulator on the alternator to control this field current in response to the alternator output voltage. So as the voltage is increasing, this regulator will find ways of cutting the voltage so that it remains within a certain range. Regulators can be mechanical or electronic. The latter, the electronic ones, are now most universal on modern cars, like I discussed earlier. The voltage, some computers on the car, some engine control modules can now even play with the actual voltage output from the alternator. Yeah, so that is what a typical regulator looks like. This is a Bosch component, probably to fit on some European car. And these regulators can be mechanical or electronic. Like I said, the electronic ones are now taking over. Yeah, that is what I had to share about alternators. I don't know, Alan, if you have any questions or comments, or are there any things you've learned? Are there any new things you've learned that you did not know before? Alan? Yes, I don't know if you have any comments or questions regarding alternators on vehicles.
Again, I just want to thank you for enlightening us about this thing, because most times we think of the battery functioning in one way. Yeah? Even the charging process, we don't think of what really happens.
That's
yeah,
because a lot
so
of this stuff happens automatically behind the scenes, so you don't even get to know what's going on.
exactly, yeah.
But just for our viewers, something I've remembered to mention is when your alternator fails, the engine, if it was running, is not going to stop immediately. Or if the alternator can stop because the wiring to it is broken, the alternator is bad, or the belt is broken, so the alternator is no longer being turned. You see that warning light that looks like a battery. That would be the first sign. You can continue on a good road if you don't have a lot of loads. If you have a smooth road, you are driving at maybe 80 kilometers an hour. It might even give you 40, 30 kilometers. You might even go that far. But trust me, just because it continues going does not mean you are not going to stop eventually. So as soon as you see that light, stop as soon as it is convenient and investigate. Otherwise, you can get stuck by the side of the road. It is easier to drive towards a garage or a repair shop while you still have some juice left from the battery. Yeah, but as soon as you see battery warning light on your dashboard, ladies and gentlemen, pay attention. Do something. You are about to be stuck by the roadside.
Mm.
Yeah.
Yeah.
That time becomes shorter. I've noticed most people have complained. That it happened to me before. The vehicle, I left Kampala, I even reached Entebbe or Kajansi, but today I did not even reach Zana. Yes, because today you are talking about you are driving at night and the vehicle, the headlights are working and they consume a lot of power. So if you have time, please go back and look at our video about the battery. You can have batteries are rated depending on the capacity of, of power they can store, the capacity. That is the so-called capacity. So you can have a battery that is old, but is able, because the alternator is working well, that is able to give you just enough juice to always start the car in the morning. You can have a bad battery for about a month and not even know about it because you are not using that battery once the vehicle is parked. The vehicle parks, you remove the key, you walk away, you lock it. Come back the next day. If you don't have things that are taking residual power from, like if you don't have small bulbs or whatever other system that should not be taking power, if you don't have them, come back the next day. If it still has like 30% capacity left, a battery will start, but it is old. Now, the day you stop and stay in the car chilling and you open the door and they call it the courtesy lamp is on for 10 minutes as you are talking on the phone, you go to your workplace, come back. That is the day the battery is likely to fail, and then you will know about it. Conversely, you can have a bad alternator. As long as the battery is still good and you are doing long trips, the alternator is charging, but not so well. It is weak. So because your trips are quite long, it gives enough time for this bad alternator to charge the battery. So you may never know the alternator is bad until, again, you use the battery too much or you do a series of short trips and then the battery run through its reserve. That's when a failing alternator will catch you. Usually there are signs before the alternator totally fails, but you will never know them because things are working in the background, and the day or time you realize there is something wrong is when you come to start the car and it fails to start. That's when all sorts of alarm bells go off. Yes.
Yeah. Thank you so much for those elaborate explanations and tips on how to keep the car in top shape.
Yeah, thank you very much too for your attention. If you have any questions or comments, please leave them in our below the video. Thank you very much.